In this video, we're going to talk about the third basic measure for numerically describing our data, which is the measure of relative position. The measures of relative position is mostly related to percentile. The kth percentile is the value under which around k% of the other sample values lie, and above which around 100 minus k% of the other sample values lie. So to illustrate the definition, let's have this example. Let's say I'm looking for the 50th percentile. 50th percentile. By definition, the 50th percentile has 50% of the dataset below it, because it should be 50% lies below it. So that's why we have that definition. And of course, if 50% is below it, the other 50% is part. And that percentile 50 belongs to the upper 50% because 50% is already below it. That's what the definition of percentile would mean. So let's have now how we compute percentiles using Excel. So let's say, for example, we're computing for the 25th percentile. The 25th percentile means that I'm looking for the score wherein 25% is below it. So to compute for the percentile, we will use a formula. We'll have there. If you type the first four letters, you will see that there's actually a lot of formula for percentile. And what we have to use is percentile INC, as it should include all the data values. So once we click that, you see that we need the array and the K. The array is actually just your data set sans the title or the heading. So we don't include it. Then comma, then the K. The K is a value between 0 to 1. Since I'm looking for the 25th percentile, I will put 0.25. If everything's okay, we click enter. And now we get our 25th percentile, which is actually 5. Just again to illustrate the definition, as we seen a while ago, our 25th percentile or percentile 25 is 5. If we're doing it the manual way, we will have to compute not for the value but for the position. That is what is shown here. And the position that we got is the 7th position. So let's count. 1, 2, 3, 4, 5, 6, 7. So it's 5, which is consistent to what Excel gave us. And based on this, the ones below that 7th position, those values already belong now to the 25% of our dataset, which means the ones here belong to the 75%, and 5, it's that smallest value of the 75%. To interpret the percentile, we will use this template. Around k% of the sample have a value less than the kth percentile. Applying it to the 25th percentile that we have just computed, around 25% shut off after less than 5 seconds. That's the interpretation of our 25th percentile. Let's have another example of computing for percentile. Let's say we want to compute for the 50th percentile, which means I would need 50% below the specific value I'm looking for. So pause the video and try to use the formula that you see in the formula bar to compute for the 50th percentile of our dataset. So let's check if your answers are correct. We'll have equals, then we need that formula. We'll select again our data without the heading. comma, then 0.50 because that's what we're looking for. Then click enter. So we got 8. Don't you see something similar to the 50th percentile? As you can see, our 50th percentile of 8 is similar to our median of 8. And why is that? It is because the median is actually a special percentile called quartile. Also, it is another special percentile called a decile. So what are these special percentiles? Quartiles divide the dataset to 4 parts. If percentile divides the dataset into 100 parts, quartiles divide the dataset into 4 parts. Similarly, the decile divides the dataset into 10 parts. So, as stated here, our first quartile, quartile 1, is actually the same as the 25th percentile. Quartile 2 is the same as our 50th percentile, which is also the same as our median. And quartile 3 is the same as our 75th percentile. Similarly, the 10th percentile is equal to the first decile, the 20th percentile, it should be just decile 1. There you go. So percentile 20 is decile 2 and so on. So these are special percentiles because they're dividing the dataset into two different parts. And now that quartiles have been discussed, we can now talk about the interquartile range. The interquartile range is the last measure of variation. The interquartile range is defined as the difference between the 75th percentile, quartile 3, and the 25th percentile, which is quartile 1. The interquartile range is the appropriate measure of variation for the median, as the two are the most resilient to outliers. So what does this mean? Let's have an illustration. Let's say we have this data set and this is our quartile 1, quartile 2, quartile 3. Our quartile 2, which happens to be our median. And the data, since we are dividing them by quartiles, they are arranged in ascending or descending order. So now, the interquartile range will only get these values here. Actually, not even the values here, but strictly from quartile 1 to quartile 3. So, even if the values change here at this point or change here at that point, it will not affect anymore the interquartile range and our median. Hence, the two are very resilient and are not affected by the very high values or the very small values, which can be rather our outliers. So if your data set has a lot of outliers, then the median and the interquartile range can best describe your data.